Good evening, everyone. We are Group 2 from Lab Group FCSA. Today, me, Aryaman, Sia, and Grisha will be presenting our SC1015 mini project. This will be the flow of our presentation. The Singapore HDB market is a market that not only provides shelter but also reflects Singapore's economic heartbeat. Despite initiatives to maintain affordability, the HDB resale market has seen a notable increase in prices with a 31.9% hike over recent years. This surge raises crucial questions about sustainability and affordability, which we aim to address through our data-driven analysis. The, re- the resale price trends in the HDB market are influenced by several key factors. A significant population increase of 41% over 2 decades against a backdrop of limited land, controlled supply of new flats, impactful government housing policies, economic strength driving demand for higher quality residences, and renovations enhancing property values. Additionally, the attractiveness of HDB flats as investment options contributes to the competitive housing market. In a city where the skyline is constantly reshaped, our project finds its cornerstone. We are not just crunching numbers, we are laying the foundation for informed decision making in the HDB resale market. By accurately predicting resale prices, we empower both buyers and sellers with clarity and foresight. The analysis serves as a guiding light in the dynamic housing market, shedding light on trends and fostering stability amid price fluctuations. We aim to enhance market transparency and contribute to the dream of affordable home ownership in Singapore. The problem statement thus summarizes our aim as follows. How can we develop a predictive model that accurately forecasts the resale prices of HDB flats in Singapore to empower both buyers and sellers and enhance the transparency and efficiency of the public housing marketplace? Our data is based on the Singapore Public Housing Dataset from Kaggle. The dataset is extremely detailed and includes 78 various features related to HDB flats. So let us now talk about the first stage of our project, data cleaning and pre-processing. The first step in cleaning involves standardizing all column names to lowercase and formatting them to snake-case for consistency, making it easier to manage the data programmatically. We also dropped all the irrelevant columns. We systematically reviewed all columns to identify any missing data. To address these gaps, we used the simple imputer strategy, replacing missing values with predetermined constants. This approach ensured that there is no data loss. To further enhance our analysis, we augmented our dataset with calculated fields. During our data review, we removed and identified columns that contain only a single unique value as they are statistically irrelevant for modeling because they do not vary. Next, we ensured that all data types within our dataset were correctly aligned with the requirements of our predictive model. This step is vital because incorrect data can lead to errors in modeling or misinterpretation.
We will now discuss the exploratory data analysis. Let's look at the resale price trends over the last decade. As we see in this histogram, a substantial portion of flats were sold within the more affordable pricing brackets. Notably, the right skew in the distribution signals that higher priced flats are less commonly sold, reflecting a market sensitive to price increases. Understanding this pattern helps us anticipate market demand and pricing strategies. Our geospatial analysis presents a vivid illustration of how resale prices vary across different regions of Singapore. Hotspots with elevated prices are primarily situated in the central areas, likely driven by their proximity to business districts and key amenities. In contrast, more peripheral zones offer a cooler shade on the map, hinting at more accessible housing prices. This violent plot juxtaposes the range and distribution of resale prices for each flat type within the public housing market. Observe the breadth and skewness in resale price distributions, where executive flats exhibit the broadest range, hinting at a high degree of price variability. Now we talk about a pair plot, also known as a scatter plot matrix. Each plot in the grid represents a pairwise relationship between the features listed on the x and y axis. The diagonal plot provides histogram showing the distribution features. We gain the following insights from the graph. The plot shows a positive correlation between floor area and resale price, which is intuitive as more space often equates to higher value. Closer proximity to MRT stations might indicate higher prices due to better accessibility, a trend to look for in the scatter plot. Older flats might have lower prices due to aging facilities unless they are in prime locations or have other redeeming features. Histograms along the diagonal show the distribution of each variable, highlighting commonalities like typical floor area sizes or common story levels. The line chart displays the median resale price trends of flats over the years. A significant dip is observed around 2016, followed by a period of stability. Post 2018, there is a dramatic increase in median resale price. This trend line helps in understanding the overall market dynamics during the decade. The box plot visualizes the distribution of resale flat prices across different towns. Each box represents the interquartile range of prices in a town, with the horizontal line indicating the median price. Outliers are depicted as individual points beyond the whiskers. Cluster analysis is utilized here to segment properties in the housing market into distinct groups based on their characteristics. This graph depicts the distribution of resale prices within each identified cluster. By examining variations across different clusters, we can infer market segmentation based on property attributes. The correlation matrix highlights the relationship between key features affecting HDB and resale prices. The heat map visually represents these correlations using red to indicate positive correlations and blue for negative ones. By analyzing these correlations, stakeholders gain valuable insights, enabling them to make informed decisions whether they are buying, selling, or investing in the market. Now we will move on to our machine learning part. We've utilized scikit linear regression function. Our model was trained on a data set containing 100 data points, ensuring that it is capable of making reliable predictions. Here you can see the code snippet that initiates the model's training process. Moving on to our model's predictions and how we evaluate its performance. We use two key metrics: the R-squared value, which indicates how much of the variance in the target variable our model can explain, and the mean squared error, or MSE, which measures the average of the squares of the errors. Let's compare the actual values against the predictions made by our model. On the slide, we have the scatter plots for the training set in blue and the testing set in green. These plots help us assess how well our model predicts new data, and the red line represents the predicted regression line, illustrating how closely our model captures the underlying trend between the variables. The decision tree regression model, which is a non-linear predictive modeling technique for capturing complex patterns in data, we use scikit's robust decision tree regressor to fit our model. This involves analyzing our data set similar to the real world scenarios, allowing the data to model to high confidence predictions. Let's discuss the predictions and how we evaluate the performance of our decision tree model. We look at 2K matrix, the R-square and MSE. Our model achieves an impressive R-square score, indicating a strong fit to the data. Meanwhile, the MSE values are low, suggesting that the prediction errors are minimal, which is crucial for accuracy. In scatter plots, the actual values are marked in blue for the training set and in green for the testing set, while the predictions are predicted in red. We've included a line perfect predictions as a benchmark, which helps us to see how closely the predicted values come to this ideal line. Random forest regression model enhances predictive accuracy by combining predictions from multiple decision trees. Each tree is built during training and contributes to the final output by averaging its predictions. A model utilizes 100 decision trees with n estimators set to 100, capturing a diverse range of data variances. We have tuned the hyperparameters like max depth and min samples leaf to balance bias and variance. To visually assess our model, we use scatter plots that compare actual data points against the model's predictions. A closer alignment of these points along with the computed best fit line using np.polyfit demonstrates the accuracy of our predictions relative to the real values. XGBoost, which stands for extreme gradient boosting. This framework is renowned for its exceptional performance and speed in handling machine learning tasks, particularly in regression challenges. One of the key strengths of XGBoost is its ability to manage large data sets while employing advanced regularization techniques to minimize overfitting. To ensure effective processing by our model, we converted all categorical variables into numerical formats using label encoding. XGBoost operates on a data structure called as DM matrix, optimized for speed and performance. We tune parameters including max depth to 3 and min child weight to 10. Our training strategy for XGBoost involved 100 rounds of boosting. We implemented early stopping to prevent overfitting and to ensure optimal performance. To validate the accuracy, we use scatter plots that compare the actual values against the predicted ones. The proximity of these points to the ideal fit line illustrates the model's effectiveness. The scatter plot shows how closely our predictions align with reality, demonstrating the model's high accuracy. This is a comprehensive model in our analysis. XGBoost generally outperforms others in terms of R-square and MSE due to its sophisticated handling of complex patterns in the data. Our model excels in predictive analysis, leveraging advanced algorithms to enhance accuracy and forecasting capabilities. It optimizes efficiency, reducing time and costs while ensuring reliable results. Designed for scalability and adaptability, it handles large data sets and evolving business landscapes seamlessly. Crucially, its ability to anticipate market trends gives users a strategic advantage, empowering informed decision-making and maintaining competitiveness. Our data-driven analysis offers a comprehensive roadmap for home buyers, sellers, and policymakers, enabling informed decisions. It aids in setting competitive prices, negotiating effectively, and maximizing returns for home buyers and sellers. Investors can make informed decisions, identifying lucrative opportunities and optimizing their portfolio for long term profitability. With this, we conclude our presentation. Thank you very much for your time and patience.